video, you're going to be learning about the exterior angle. How can we figure out how large the angle is if we have some clues about the arcs that are on the circle that is beside the angle? If you remember, we did interior angles in the previous video. To figure the measurement of an interior angle, you need to average arcs together. Take two arcs and add them together and divide by 2. For the exterior angle, the formula will be similar, but not exactly the same. So we're going to figure that out together before we actually work on a couple examples. Let's begin with some facts that we know about inscribed angles. Angle EBF is an inscribed angle. An inscribed angle is worth half as much as the arc that it intercepts. And we can call that arc. Since we're not working with a specific circle, we can call that arc x degrees. Now in this picture there's also another interior angle, another inscribed angle, angle E. And angle E is half as much as the arc DB, which I'll put a Y there since we're not working with specifics. So however many degrees that is worth, angle E is worth half as much. So those are some facts about inscribed angles that we know. If you watched the last video, we talked about exterior angles of a triangle. So EBF is an inscribed angle on the circle. It's also an exterior angle to triangle BCE. And we know that the angles that are on the outside of a triangle are equal to the two remote interior angles added together. So we've got 3 facts here to start off with that's going to help us build our formula. Just as I did in the last video, I made some replacements or substitutions. So EBF could be replaced by half of x, angle E could be replaced by half of y, and I won't replace angle C, I'll just leave it as angle C. What I'm trying to come up with is a formula for angle C. And I've got it right here. I just have to do a little rearranging. So if that fact is true, that means that angle C would have to be equal to half of angle X minus, if we subtract half of Y from both sides, minus half of the degrees in Y. And that's a formula that we could use to figure out the measurement of C. But just like in that last example, the last formula, I'm going to do a little, rearranging here, a little house cleaning. I can factor out an X, I can factor out a 1/2 from both of those terms. And then I'll just rearrange it. So the exterior angle is equal to the 2 arcs subtracted from each other divided by 2. So instead of adding the 2 arcs and dividing by 2, we're going to subtract them. Now you don't have to know where this comes from necessarily to answer questions, but this is showing you that this formula isn't just falling out of the sky. So let's actually take a look at some specifics here. First of all, a word that we are pretty new to, I'm sure, or maybe brand new to, is the word secant. Exterior angles are formed sometimes by 2 secants. Now the word secant almost sounds like the word second, and that is because it has this fact that's true about a secant. A secant goes through a circle twice, like second. So this is the first place that the secant hits, and that is the second place, the second point. So that's a secant, and this is also a secant as well. So let me make it a more specific question by adding in some numbers. So suppose that we start off with an arc measurement here in blue of, to me that doesn't look like, I'm making the question up, that does not look to be like half of a circle, it looks much less. We'll call that 100 degrees in blue. And if I'm making this look realistic, I would say that green arc there is around 30 degrees. Now my goal here is to figure out the measurement of angle C, so I can apply that formula that we just went through. Angle C is not equal to the average of the two arcs, but the two arcs subtracted from each other. So the blue minus the green, and then divided by 2. So 70 divided by 2 brings me up to 35 degrees for angle C. And of course, that looks to me to be very realistic when I go back to the picture. So a real short lesson for you today. I just have one other example to show you too. In this case here, we're not looking for the exterior angle. We already have the exterior angle, and we have one of the arcs, it being 66 degrees. This question says to find the other arc from E to F. So in this particular question, we're going to have to apply that formula, but in a slightly different way. We're going to call that missing arc in blue X and snap it into that formula. The angle on the outside, 50 degrees, is equal to the blue arc, which is X, take away the green one, 66, divided by 2. To get rid of dividing by 2, I'm going to do the opposite of dividing by 2. I'm going to multiply both sides by 2, which brings me to 100. And the 2's on the right-hand side cancel each other out. So 100 equals X minus 66. And then simply just get X by itself by adding 66. And we get that the blue arc is worth 166 degrees. Taking the answer back to the picture is a good idea. So 166 degrees for that blue arc seems realistic. When I think about what a half a circle looks like, a semicircle would have to go from E to A and all the way across that way. So just by taking a step back and taking a look at this answer, the curly arc there is a semicircle that I just drew in, so that would be worth 180 degrees. And the blue one came out to be 166, so it seems totally reasonable to say that that answer is correct. In fact, sometimes they actually make these questions just a tad bit more complicated. They'll add on an extra point like this. We'll call that W, and they might want to find out the measurement of FW. So if the curly arc was 180 and the blue arc was 166, the part from F to W would have to be 14 degrees. It would have to be the rest of it to make it 180 degrees. So occasionally you might see a question like that, which makes it a little bit more advanced. So let me just show you the questions that I'm assigning. So we got question number 1 and question 2. Question 3 and 4. Question 5 has you using some algebra, finding the value of x in both of these diagrams. And then the last question for the assignment is one where there's not even a picture of the exterior angles. I just leave that as a challenge for you to solve that question without a picture. Well, I would actually draw a picture as the first step, and that's what you should do as you're determining the answer to this. So once again, that is it for today, and have a beautiful day.